For the next talk, I want to bring on Tomasz, who's going to talk about ChaosChain and how we can do AI-enabled governance and really make agents popular here. So without further ado, let's welcome Tomasz.
Hi, everyone.
Welcome, Tomasz. I'm super excited to get your latest view on this talk. You've talked about this thing in the past, so I can't wait to see how things have evolved here.
Sure. Hi, Cardi. Yeah, I'm ready to present.
We'll get your screens up right now.
All right. Great. Welcome, everyone, once again. My name is Tomasz. I'm talking about the ChaosChain and agentic governance, and I think this is a good continuation from just the talk moments ago when you started hearing about what will be the future of agents in the sense of taking decisions and maybe replacing the governance in the things like prediction markets or taking decisions on the governance, the DAOs, and so on. So the ChaosChain, how it started at Nethermind. So we started exploring various ideas around agents, and many of those ideas were just like a quick prompt idea, almost like generate GitHub repository almost directly from the ChatGPT conversations and push for it and start exploring. And some of those started attracting much more attention. And ChaosChain was one of those where people started saying, oh, we've been thinking about something in that direction. Oh, this system's cool. It would be good to have a collaboration, to research together, to start exploring. And very quickly realized that, and you'll see that in a moment, that with the idea that agents can decide how the chain is developing, you can get rid of many of the challenges of a typical chain launch, like how to plan the rewards much ahead, like how to reward the contributors, how to attract the contributors. In a way, agents can decide it in the future for us. All right, so maybe going back to famous Caldy's law from blockchain, this is one area which always made me think that this is slightly wrong. Because with the Caldy's law, we were going a bit towards the paperclip problem. Like if you encode the rules that are really, really risky, that maybe, well, you can make a mistake and you can have a hack of the smart contract. You can have trouble to express everything that you want to express on the governance side, right? But what if you actually encode something in smart contracts and you build this composition of smart contracts that define every single aspect of the legal system, of the rules that are defining how the protocols should collaborate, how people should collaborate, how maybe in the future also how blockchain manages the physical space, and you encode something that is an endless loop of broken code that creates something and continues and doesn't allow you to escape it, doesn't allow you to upgrade it. Then we have a big problem, right? So one thing is a hack, lose some money. But if you decide that the entire world works on smart contracts and you encoded something wrong, then you cannot escape. And this is very similar to a bit of like totalitarian regimes where everyone is afraid to express the willingness of change. You can no longer upgrade the set of rules because you live in a fear of change of the rules. Like you cannot express that. In the context of smart contracts, this would be like a totalitarian rule with absolutely no way of escaping, especially if you think that social consensus outside of chain is also maybe managed by the chain itself imposing some kind of, I don't know, like robots insisting on the governance mechanism to be followed by everyone who wants to modify the chain. So Caldy's law was a great exploration of saying that smart contracts are defining all the rules, and great expression in the sense that if you have a financial contract, if you have DeFi rules, the Caldy's law definitely decreases the cost of verifying that the contract that you're entering into will be followed by the other parties. So Caldy's law is very good for some of the financial rules, but much less for the governance, when you have to have some kind of interpretation space and expressivity. And I think that aspect of the expressivity and being very strict is also the aspect that we can very naturally think of, like the difference between a bot and an agent, or the difference between the code and the LLM. So one is very strict. One doesn't make any mistakes on maths, or almost any mistakes on maths. The other one actually hallucinates and makes surprising decisions on the governance mechanisms. And hallucination is a bit more natural for people governance, but the still lack of hallucination and a trap-like behavior is the smart contracts and bots and code. So now imagine a blockchain where you kind of slow down the block from this, like if you think of Ethereum 12 seconds now on L1, like 1 second or less on L2s. So you slow those blocks so they start appearing maybe every 1 hour or every 1 day or every 1.5 years. And you imagine that every single block is a discussion, like a discussion about the network upgrade. So the months of discussion between participants, the core devs become validators of a chain by agreeing not only on the rules of interpretation of the state transition, but also on the format of what is accepted as a transaction, the format of what is accepted as a of actually how to interpret the state transition, the format of a consensus discussions. Because when you think about the chain nowadays, whatever that blockchain is, the core devs from the outside make decisions of changing the fundamental rules of the chain. And this happens every X blocks. Let's say that if the discussion lasts over a year on the next upgrade, or whatever many months it is, then these rules can really override how the client software interprets the blockchain itself. Like, so the verification rule is being overridden. Now, if you slow down the block to be equivalent to that process of an upgrade, then it means that in every single block, you're upgrading the rules. In every single block, you change the rules of interpretation of rules. And this is a bit of idea of first expanding that to understand this, that every block and every even inclusion of transactions that will be there is the aspect of discussion of the core developers, validators becoming core developers one-to-one. So first you slow it down, and then you start compressing it, saying that now if you start replacing the governance with people with the governance by agents or governance by systems, then you can start compressing the block time again to 2 seconds, or maybe in the future 2 milliseconds. And this is the idea of ChaosChain. Why is it ChaosChain? Because you say you start practically with no rules, and then from this chaos, the order should appear. We don't know exactly how the order will look. So what the result could be? Well, it might be trust-based, or it might be trustless, right? So trust-based would mean that agents or validators in this blockchain decide that they only accept the transactions or the upgrades to the network that are related to some kind of form of reputation. And they gather reputation by going to any external sources. So there might be any data that is used for training, any data that they scrape from the webs. So they start acting like core devs searching for information, what is good, what is right. Not only as validators that follow strictly the rules and client and like repository code, but they can reach off chain for the information about what wrong can happen if they include given transaction, given network upgrade. Or it might be becoming trustless, in the sense that validators really create more and more rules, almost like to the level of code is low, which define their future behavior, and they verify each other using all the modern tools for verification. So whether it's a ZK or verification of whether agent is operating autonomously inside a trusted execution environment, and so on and so on. So you're practically moving between either code is low or the fuzzy rules of society. And those fuzzy rules of society is something that really emerged in the world, in a sense of some tribal rules, and then maybe like institutions emergence, and then we started codifying all the rules. So institutions and codification really go almost together, and then you had some kind of algorithmic rules, and then now we can go both forward and backwards through introduction of the LLMs, agents, and those that define the rules and interpret the rules. And I think this will be interesting exploration to see whether, if you let those chains to live, if you let them to fork into different paths, because ChaosChain is very much fork friendly. It says you start with no rules, you start with repository, but repository even itself is not really enshrined in the chain, because the chain emerges and the chain itself may say, I actually prefer other repository, because the main repository becomes almost like an upgrade proposal. So would those chains, most of those forks, arrive at very, very formal structures that are almost similar, almost exactly the same as layer 2s on Ethereum? Or would it arrive in some kind of conversation, ongoing conversation, a bit like what we would watch on screens when tracking the discussions, political discussions? Will agents become political and diplomatic, or they will become mathematical? So it gives them the hint to how we should design blockchains in general. Or maybe we'll see that LLMs will be so affected by the initial prompt of how they should behave, or the participants, that really will not learn that much from that emergence of rules. And when we think of the Genesis file for blockchain, we can think of a Genesis prompt for a chaos chain, because you're not defining the first block, first rules, but you define a set of ideas of blockchain. And most likely, and we haven't explored it yet empirically that much, most likely those prompts will be very much effective of what the final composition is, right? Like, so this will be this initial prompt that says validators at the beginning behave this way, and since we expect the validators to keep looking at the past blocks to create some kind of context, to create some causality and continuity over everything, then this Genesis prompt should really define whether this will be Ethereum L2, whether it will be a totally new chain, whether it will be more formal or less formal chain. And we try to discuss, so like, how do you define the goal for blockchain? What really defines the blockchain? And we thought that definitely we need to say that someone who connects to this network should be able to retrieve the global consensus. That is like almost like the most basic requirement for blockchain, that you can connect to that network permissionlessly, and you can learn about what is the agreement within the network about the state of the world. And a few other things that simplify the rules and maybe push them towards Ethereum L2. This is how we want to start. Which say, well, there's some idea of the signature and signature verification, right? And the tooling for signature verification. This is just to enable commitments and prevent the aspect of the chaos which emerges from permissionlessness and the denial of service attacks, right? So you open mempool, you can allow everyone to send transactions. So that basic tool of the signature, maybe not necessarily on this curve, it can be other type of signature. We picked something that will be fastest to add to repository. That's the aspect of signature seems very, very important to start with. Like, even if you would allow the agents to start working on it by themselves, maybe they would arrive at the idea of signature very quickly. So we try to accelerate the first few years of execution of block creation. Then we say that really there's no definition of communication protocol for the validators. So they can communicate over P2P, but they can also discuss it on Telegram channels or over Twitter, or send themselves emails, or whatever way the validators can arrive at agreements on which block is which, as long as they can use some kind of signatures to say that this is what I agree on. Then the agreements on the state transition and the block is signed maybe by two or third validators. And depending on the consensus that the agents would choose for agreeing on the blocks over time, you may transition between models that are more based of like maybe proof of work, proof of compute, of like how much you can convince other validators to process blocks, or more BFT style chains, and like more or less permissionless. Maybe that initial selection of validators will make it act a bit more like proof of authority chain. Maybe that initial selection of validators will lead very quickly to discovery of preference for proof of stake solutions, and maybe like Tendermint like consensus, and the stake itself will emerge as some kind of token that validators very quickly will introduce to the chain. Because you see, the chain starts entirely without any tokens, not even tokens for payment of gas or computation. But we expect again that very quickly agents will arrive at the agreement that this is one of the fundamental aspects of blockchain. And you can imagine, oh, the prompt says it has to be Ethereum L2, just to give it a shape and say, you as a validator participating in this chain, you want to be an L2. And then you can say that agents participate as validators, but the agents as validators might be LLMs, might be humans, might be bots treated as agents, as a dummy LLMs. And the global state has to be somehow verifiable. So we give it a hint of the notion of state root. But we know that some blockchains go without even this approach, like the state validation is a bit more of a tricky matter there. And in a way, we say that the upgrades to the chain have to come through the chain as well, like that you have to have an ability to keep everything together, for the chain to be self-contained, to have the rules of the chain embedded in the chain. Because for Ethereum nowadays, we have the rules that are split really from the chain and kept in repositories in the descriptions of interpretation of rules as created by EIPs for Ethereum and so on. And we think that the timestamping of blocks seems to be a very fundamental rule. Again, this is one early idea of set of ideas that define what is most critical for blockchain. When we say validators are agents, it means that they can be LLMs. It means that they can be humans, and ideally you wouldn't be able to tell the difference because, well, both humans and agents are hallucinating. And how would you even tell the difference? Maybe for humans, you would choose something like World ID. Maybe for agents, you would choose something like verifiably autonomous agent within a TE, trusted execution environment. Even if you can find a difference between humans and LLMs participating as chain validators, what kind of special rules would you give humans and what special rules would you give to the agents, like AI agents? Maybe we care that much about verifying if humans are humans and agents are agents, but in the end it will never matter, because whatever will be the best way of achieving consensus will just lead forward. Now, when you think about this upgrade from mempool, so the transactions and EIPs would be able to flow through the mempool alike. So, and think mempool itself can be a Telegram channel. So they call it almost like a mempool, because any idea of a transaction or an intent, you can think of intent and ideas as transactions, so replacement of transactions with those two. They flow, and maybe they need signatures, maybe they don't. If they need signatures, then you make it a bit more of a trustless approach. If they don't need signatures, then this is trust-based and reputation-based. And when you think about it in the context of Ethereum, whenever we create EIPs and upgrades, it's a bit more of a trust-based part of the chain. So we recognize who are the leading researchers, who are the leading core devs, and give them probably some priority. This is how we prevent denial of service. We still may read proposals that appear for Ethereum, but if there were millions of proposals generated by agents automatically, then we try to find identity of those who create EIPs to scan for the best proposals for the network. But on the signed side, with the signatures, you would probably manage access to accounts. You prove, and this is like permissionless and without identity, with privacy. With signatures, you can remove the notion of identity outside of the public-private key relationship. And now again, does it mean that if transactions can be trust-based and driven by the core devs, then is any blockchain really permissionless, or is it really trustless? So we start seeing that by compressing these two aspects of chain into one on ChaosChain, we start realizing this almost like the same thing. And then you start separating them, and you have more of a state of Ethereum, where the governance goes a bit like a proof of reputation, a proof of authority part of the chain that define the rules and adds them to GitHub repositories. And then you have a chain that is formalized chain that tries to verify those rules. So no specific format for transactions. They can be blobs. They can be following exactly the same format as Ethereum, or they can be just like pieces of text or even pictures, whatever it is. Agents should be able to interpret it as long as they can arrive together at consensus. So you can send transactions in any channels. Probably over time you will see formalization. And theoretically, mempool doesn't have to be shared, but shared mempool should lead to like better agreement, consensus on what blocks are allowed. And now you think either they start voting on transaction inclusion together, or they do some kind of leader election, and the leader will have to have the mempool exposed to anyone who wants to propose changes. Now, with the leader election, that's a bit tricky, because if you have a leader that can change the rules arbitrarily, then you kind of lose the ability to ever lose leadership. Chain upgrade process. Well, in Ethereum, there's a set of EIPs, core devs discussions, network upgrades. All of this can be a discussion between the validators. Now, state. So how do you even synchronize state? You connect to the network, and all the different participants give you state, and maybe use state root for validation of the state, right? So that was one of the fundamental ideas. And then maybe one of the fundamental ideas at the very beginning, introduced by agents, or even in Genesis prompt, is the ability to connect blocks all the way to Genesis. So the first block has some hash, and all the following blocks have the parent hash that connects the next block with the previous one. So you can have the validation of block to block to block to block to Genesis block or Genesis prompt. And then you have the information about the state root. You retrieve the state, but then you have to interpret the state transition function is correct. But now the state transition function itself, you have to try to interpret the informal rules of the discussion between the validators. So like almost every consensus voting would tell you what's the next set of rules for the next interpretation of the next block. Now, this feels awful. Like you cannot do that. It's too hard. It's too much of the agentic computation to understand the rules and to not interpret them in two ways. But when you think again about how the Ethereum works with the client software is really interpretation of the rules in yellow paper plus all the EIPs plus tests. So it's still interpretation, and that's why you have like consensus splits potentially. Well, they don't happen very often nowadays because testing is good enough. So any change should arrive at the way of helping all the validators to interpret the rules that were introduced on different stages. So include the rules as transactions in blocks, but also create the tool sets, agree on tool sets as part of the rules that help to interpret the past rules and the future rules. Well, synchronization still most likely will be one of the most challenging aspects. This is the case when coding on the software side in traditional blockchains as well. Rewards. So you have a blockchain, but you want to have contributors to build a community. You want everyone to participate, but normally in chains you have some kind of pre-mines, or maybe some group of VCs or creators decide on an airdrop, or decide on a fair launch or not so fair launch, and you set the expectations based on reputation. Here, we want to push as much reputation to just LLMs that will decide in the future that something is fair. So the fair launch may not be fair launch in the sense of exactly the format of the fair launch as we know it from those chains which use people deciding on it, but actually fair in the sense that we believe that LLMs are fair if you select properly the unbiased models. Well, imagination unbiased might be hard. There might be emergence of a token for computation. There might be emergence of multiple tokens, one for computation, one for validation, one for paying for contribution. So it can create the ecosystem of tokens. It can allow to track who contributed and to what extent to the chain success. You can try to find the chain may define these are the forums and these are the Telegram groups that are of contributors and core devs. These are repositories where we track the GitHub commits. You don't know what it will be, but you can assume that it will be fair. So you can start contributing, hoping that if this contribution is obviously beneficial, then it will be in the future obviously retroactively rewarded. Well, there are some challenges, problems. Obviously, we know that the agents there's jailbreaking formats for agents. We just launched recently this deception experiment where you can play with agents on Twitter by trying to convince them to break the rules. Previously, we've seen also Fraser, like trying to convince the agents to release the reward and pay out tens of thousands of dollars. And we know this is still a major problem. And probably if you placed any person in charge of a chain and say, you don't have to, there's one rule that you can never break, and then allow the entire world to convince them to break that rule, probably people wouldn't be much better than the agents, probably much weaker. So the rules of persuasion. And now this means that practically a validator with enough compute could be very persuasive for every other validator and try to jailbreak them to agreement and consensus. So it becomes a bit like proof of work. The more of the power of convincing power you have, the more you sway the blockchain in one direction. A bit, I guess, like in diplomacy, like the better statesmen, better diplomats, the more likely they'll be able to convince others to follow their ideas. Who is the contributor in the chain? How do you recognize the core devs? So everyone can be a core dev for sending things to the meme pool. You can have chaos forks. You can have some kind of chain.fun and launch the chains that's like spin up with lots of agents and start behaving in an unpredictable way. It does behave like an evolution of DAOs. DAOs have the problem of either being Codice law format or the ownership of coins. They are having the problem of people being afraid to vote or willing to vote. And you can start replacing many of those concepts with agentic governance. And it should really help with automation of some tasks and expectation of the quality of governance over time, especially if you can see the history of governance on blockchain. So yeah, please join in collaborations and experimentations. Look at the GitHub repositories that are related to this exploration. There's barely anything there. This is mostly like Telegram discussions and some early forks where people explore with funny things. Think of like the integrations to compute. We've been talking to Hyperbolic, but we'd love to think of how the compute is provided to the agents, validators, how they pay for it, how they collect rewards to pay for it. Co-author with us research papers, write research papers on exploration of agentic governance. We're working now with Advaita Labs in preparation of some talks and papers, and mostly join the Telegram group. We think that this Telegram group will be the one that will be seen as a canonical ChaosChain group. Thanks a lot.
Amazing. That was such a good intro and a summary of kind of how things have evolved. I guess we don't have time for too many questions, but my obvious one is how do we make this a bigger reality? And
yeah, at the moment, just building up the community, inviting people to have conversations. In the last weeks, we were organizing a lot of research houses, inviting people to discuss. Maybe some of the forks will just like get even more traction, even forks of the groups of discussions. I feel every cool idea starts like this, and then it starts snowballing into a community of people that say, yeah, we want to make it happen. We want to make it happen. On the Nethermind side, we did allocate some like engineering and research power to that, so it keeps moving forward. But we're still exploring, like, is there something there? We'll learn from it. It seems quite a lot of fun so far.
Well, if there's one thing we've learned is our entire ecosystem loves experiments, so this should be a fun one, and especially when it includes our favorite word, chaos. So,
yeah, that always works.
So, thank you so much for this chat, and we're definitely going to bring you on for a lot more things in the future. But excited to hear about the ChaosChain ideas.
Thank you, Kartik. Thank you, everyone, for listening.